Hi everyone, welcome to today's class on chemical reactions and equations. We will be doing some more examples of balancing of equations today. We had seen this reaction in the previous class, zinc reacting with hydrochloric acid. The products are zinc chloride and hydrogen. This reaction we had observed in the previous class. Now let us write the skeletal equation first. So when you write the skeleton equation, we'll have to write all the formulas correctly. So zinc is Zn, hydrochloric acid is HCl, the product zinc chloride is ZnCl2, and hydrogen is H2, being a gas. Let us see the number of atoms of reactants and products. Number of zinc atoms is 1 on the reactant side. Product side also zinc is equal to 1. Number of hydrogen atoms in the reactant side is 1. Product side it is 2. Number of chlorine atoms in the reactant side is 1 and product side is 2. So you can see zinc is already balanced. We need to balance hydrogen as well as chlorine. So how do we do it? So let us balance hydrogen first. You have to put the coefficient in front of the formula. So it will be zinc Zn plus, we will put 2 in front of HCl to balance hydrogen atoms. So you get ZnCl2 plus H2. Now you can see the number of hydrogen atoms is balanced. Now we need to see the chlorine atoms. Now when we put 2 in front of HCl, the number of chlorine atoms has already become 2. Now let us check the whole equation. You can see number of zinc is balanced, hydrogen is balanced, chlorine is also balanced. Therefore the equation is balanced. Let's see the next example now. We have also observed zinc reacting with sulfuric acid, Zn plus sulfuric acid, zinc plus sulfuric acid. The products are zinc sulfate and hydrogen. So let us write the word equation first, then we will convert this into skeletal equation, and then we'll see the balancing. So zinc, so we are writing the skeleton equation now. Zinc is Zn, sulfuric acid is H2SO4, and product is ZnSO4 plus hydrogen is H2. Let us see the number of atoms of reactants and products. You can see number of zinc atoms is 1 on both the sides. Hydrogen on the left hand side it is 2, and on the right hand side also hydrogen is 2. Now you can see number of sulfur atoms on the left hand side is 1. On the right hand side also sulfur atoms is 1. Now you can see the number of oxygen atoms. On the left hand side it is 4. And on the right hand side also it is 4. Now you can see this reaction is already balanced. So we don't have to do anything. It's already balanced. So there are certain reactions which is already in the balanced form. So we don't have to do anything about it. Let us see another example. We had seen this reaction also in the previous class. lead nitrate reacting with potassium iodide. The products are lead iodide and potassium nitrate. Let us write the skeleton equation of this. Now let us try to balance it. You can see nitrogen is not balanced, oxygen is not balanced, even iodine is not balanced. So where do we put the number first? If you balance nitrogen, you'll have to make a number of nitrogen atoms on both the sides same. So we will put 2 in front of potassium nitrate, KNO3. So the equation will become PbNO3 twice plus potassium iodide is Ki. It gives PbI2 plus, now you put 2 in front of KNO3. So it will become 2KNO3. So nitrogen is balanced. But when you put the coefficient, you also have to see how the number of other atoms change. Because when you put a 2, it is not only potassium, which is the number of potassium which is changing. Number of other atoms are also changing. So you can see number of potassium now has become 2 on the right hand side. And oxygen has become 6 on the right hand side. Similarly, on the left hand side also it has become 6. So 6 oxygen on both the sides. So oxygen is also balanced when we try to balance nitrogen. Now let us see what happened to iodine. What about the potassium? Potassium is not balanced. On the right hand side we have 2 potassium. Left hand side we have only 1 potassium. Iodine we have 1 on the left and 2 on the right. So you know what is to be done. Let us make 2Ki that will balance both potassium as well as iodine. So now the equation becomes PbNO3 twice plus 2Ki so we put 2 in front of potassium iodide. So it will become PbNO3 twice plus 2Ki gives PbI2 plus 2KNO3. Now see whether the equation is balanced or not. We can count all the number of all the atoms and see. Right. So potassium also has become 2 now. Iodine is also balanced, and nitrogen we already is balanced, so it has already become 2. So all the atoms are balanced now. Let us see one more example. So this equation is balanced. The next example is hydrogen burned in oxygen or reacting with oxygen, and this gives water, as you know. Now let us write the formula of all the reactants and products correctly. Hydrogen is H2, oxygen is it O or O2? So see whether this equation is right or not. Right now the number of atoms are balanced on both the sides, but can we write the equation like this? Obviously not, because oxygen being a gas exists as O2. So we have to write H2 plus O2 gives H2O. Now we will balance the equation. Let us see the number of reactants and products. Hydrogen is 2 on the left hand side. That means number of reactants. Whereas on the right hand side, we have 2 hydrogen atoms. Oxygen in the reactant side 2, product side it is 1. So oxygen is not balanced. Hydrogen is right now, it is balanced. So you know what is to be done. We will put coefficient 2 in front of the product H2O. Now you can see the water molecules are balanced. The number of oxygen atoms are balanced, but see the number of hydrogen atoms. So we have to make the number of hydrogen atoms 4 on the left hand side. So we will put a 2 in front of H2. So it will become 2H2 plus O2 gives 2H2O. So you can count the number of atoms of all the reactants and products. You can see it is balanced because number of hydrogen atoms now has become 4. So this equation is also balanced now. Let's see the next example. Silver nitrate is reacting with hydrogen sulfide. What is hydrogen sulfide? H2S is hydrogen sulfide. Yeah. So what are the products? You get a silver sulfide and nitric acid. Now we will write the skeleton equation. As you know, silver nitrate is AgNO3. Hydrogen sulfide is H2S. And you get silver sulfide, which is Ag2S. Plus nitric acid is HNO3. Number of silver atoms, you can see it is 1 on left hand side, and on the right hand side it is 2. Number of nitrogen is 1 on the left, and on the right also number of nitrogen atoms is 1. Oxygen on the left hand side is 3, and oxygen on the right hand side also is 3. Now hydrogen on the left is 2, and on the product side it is 1. Now we have to see sulfur also. Now you can see silver is not balanced, nitrogen is already balanced, oxygen is balanced, hydrogen is not balanced, sulfur is balanced. So first we are balancing silver, so we put 2 in front of AgNO3. So it becomes 2AgNO3 plus H2S gives Ag2S plus HNO3. So silver is balanced now. Now we go for nitrogen. When we balance silver, nitrogen became 2 on the left hand side, on the reactant side. So it is not balanced now. So we have to balance nitrogen now. So how do we do that? Put the coefficient in front of HNO3 on the right hand side. So it will be 2AgNO3 plus H2S gives Ag2S plus 2HNO3. If you already understood how to do it, you can post the video and try to do it on your own. Then now hydrogen on the right hand side has become 2, so hydrogen is balanced. Nitrogen is the 2 on the right hand side, and on the left also it is 2, so nitrogen is also balanced now. Now look at oxygen. We have 6 oxygen atoms on both. Nitrogen is balanced on both the sides now. Now look at oxygen. Oxygen on the left hand side, 2 into 3, it becomes 6. And on the right hand side also, number of oxygen atoms is 6. 2 into 3. So oxygen is balanced. Nitrogen is balanced, hydrogen is balanced, sulfur is also balanced. So equation is balanced now. Okay, that's all for today's class. See you in the next class.